I'm a retired doctor of medicine, and in this short film I want to explain why I'm concerned about the jet streams and climate change. But first, let me emphasize that I am not a climate change denier. Indeed, far from it. I find the recent global increase in extreme weather events alarming. The International Panel on Climate Change, or IPCC, is concerned, and some scientists are even warning that we're heading for a potentially catastrophic hothouse Earth scenario. There's general consensus that the jet streams, and especially the North Polar one, are misbehaving, and blame is entirely laid at the door of greenhouse gas emissions. But what if this conveniently minimises other direct effects of commercial aviation, which the IPCC says contributes a mere 3.5% to anthropogenic climate change? Any child can see the ever-increasing aircraft contrails, while as airline passengers we are comfortingly reassured that we can neutralise the harm caused by buying so-called carbon credits. But might this conveniently hide an even more inconvenient truth about jet stream abuse? The jet streams are 4 high-speed ribbons of air that flow eastwards and lie at a height of around 10,000 meters plus at the tropopause, which is the interface between the troposphere below and the stratosphere above. They measure 1 to 3 kilometers deep and up to 300 wide, and have very fast flowing cores of 200 to 400 kilometers per hour, and they drive the weather below. They result from the rotation of the Earth, the Coriolis effect, and the interfaces between large bodies of rising hot and falling cold air. While mainly flowing from west to east, they also show north-south oscillations, or so-called Rossby waves, which move more slowly in the opposite direction. When these oscillations become extreme, as is increasingly the case, they sometimes get tied up in static and persistent knots of high or low pressure. And because the Earth rotates with a tilt of 23.5 degrees relative to its annual cycle round the Sun, they move north and south with the seasons. And as 68% of the Earth's landmass lies in the northern hemisphere and is overflown by the North Polar jet stream, this one may be the most important. But is another climate change question being ignored? Well, climate experts tell us that recent extremes of weather are due to increasing oscillation of the North Polar jet stream, and they attribute this to increased CO2 emissions, with no mention that I can find of another obvious fact. That is that for 65 years, and ever increasingly, the jet streams have been used to reduce eastward aircraft flight times and so to save on fuel costs. The same climatologists seem persistently to avoid the resulting obvious question, namely, what is the effect of these same jet aircraft on the flight of the jet streams? If they don't even acknowledge an obvious question, might it, emperor's clothes style, be one that is more than an expert's job's worth? Let us consider the interaction between climate monitoring meteorologists and the airline industry. The former use sophisticated satellite and other methods to monitor the position, speed and direction of the jet streams, and then advise where the planes should fly at cruising height. Most of the world's money and airline flights are located across the North American and Eurasian continental landmasses. So the North Polar jet stream especially is used whenever it increases ground speed and so reduces flight times and fuel costs. It's as if the jet streams exist purely to reduce airline costs. And meanwhile, the aircraft industry is doubling every 15 years, so this process is set to get ever worse. It's 330 years since Sir Isaac Newton formulated his three laws of motion, and they still hold. The first states that a moving object stays in motion with the same speed and direction unless acted upon by an unbalanced force. In the case of an aircraft, that force is gravity. The third states that every action has an equal and opposite reaction. Therefore, if an aircraft hitches a lift in a jet stream, there must be an equal and opposite effect of the flight of the aircraft on the flight of the stream. Aeroplanes are not like balloons or boats that float because they're lighter than the surrounding medium. They're much denser than air, need to oppose the force of gravity, and they do this by generating lift. So how is an aircraft's lift produced? Lift is produced by the reactive force on the aircraft from the backwards thrust of the engines being deviated downwards by airflow over the wings. According to Scott Aberhart and David Anderson, no relation, the lift of the wing depends on its shape, the angle of attack, and the viscosity of air flowing over its upper surface. The lift produced is equal to the change in the momentum of the air the wings divert downwards. At cruising flight, when just enough lift is generated to keep the aeroplane level along the direction of airflow in a jet stream, around 93% of the force of the engines is expended on lift, while the rest opposes other sources of drag as it moves the plane forward. So it follows that each aircraft flying in the jet stream must be forcing down an equivalent weight of air and so lowering the height of said stream. But relative to the whole atmosphere, aren't these effects trivial? Well, let us just consider use of the North Polar jet stream crossing the Atlantic. The total mass of the whole atmosphere is 5.5 times 10 to the 18 kilograms, of which 1/4, or 1.35 times 10 to the 18, lies above the tropopause, and a small fraction of this is in the four jet streams. Let's assume that 1% lies in the North Polar jet stream. That would be 1.35 times 10 to the 16 kilograms, of which maybe 10%, 1.35 times 10 to the 15, runs over the North Atlantic. Around 2,500 aeroplanes, averaging about 250 tons each, fly across the Atlantic each way each day. And this constitutes a downward force of 6.25 times 10 to the 8 kilograms. If we multiply that by 365 days a year, we arrive at 2.3 times 10 to the 11 kilograms. And that is just considering only a tiny part of the picture, because within the USA alone there are a staggering 30,000 commercial flights a day, many of them also using the North Polar jet stream whenever it happens to increase ground speed and so reduce airline costs. And of course, where the jet stream doesn't travel, Rossby-wise, in the desired direction, it's avoided. So we may expect marked vertical distortions of what should be harmoniously flowing tunnels of air. I worry that the scientific business of meteorologists and their job's worths may be rather too closely intertwined with airline flight paths. The business of airlines, of course, is to move people from one place on the ground to another, and so, of course, they want to maximize ground speed. Cadging a free lift in the jet stream makes this easier and is their immediate financial benefit. But who is paying for their short-term convenience? Newton-wise, doesn't every financial transaction carry with it an equal and opposite reaction? And if so, who is paying? The jet streams have much more important natural functions than the artificial one of speeding up flights. Is it not therefore high time for some properly controlled studies to be conducted to explore the effects of these unnatural anthropogenic forces on the drivers of our weather? Because we have no idea where the tipping point might be. It's been estimated that the cost of climate disasters in the USA alone last year was $306 billion. So how about setting aside 1/1000th of this for such research? Well, how high are the disaster stakes? The stakes might be very high, as if the air is mixed enough, there's surely enough heat at the equator over time to melt the ice caps. And if all the polar ice were to melt, sea levels would rise by between 60 and 70 meters. And airports for Miami lie a mere 3 meters, New York, San Francisco and Vancouver 4 meters, and Rome 5 meters above sea level. And what about London's Heathrow? Well, if a mere 7% of the polar ice melts, there'll be no flights to or from the now submerged low-lying airports mentioned above, and so no need for a third runway. So let's draw some conclusions. I contend that there is an urgent need for some proper science. So it's even in the long-term interests of the global airline industry to invest some of its current profits gained from flying in the jet streams into financing serious, independent, controlled scientific experiments to test two opposing hypotheses. The first is that abuse of the jet streams by passenger jets has no adverse effect on them and the weather they drive. And the second opposing one, that it does have a significant harmful effect. If so, how big is it? What needs to be done to stop and reverse the consequent damage? It might be as simple as having all planes fly lower and well away from the jet streams. Yes, this will cost money, which will have to be passed on to the globe-trotting traveller, but then he's flying around too much anyway. And there might well come a point where it's too late to ask because we have passed an irreversible tipping point. Thank you.